Alright, today on Mesa Makes we're going to be making this simple yardstick box. It's something I use in my class all the time. And the key to this project is knowing where to place this divider, and today I'm going to show you how to do that using the Planar Mate. So stay tuned. Alright, so if we jump into this project, essentially what this is, it's a like a box to put like pens and pencils and stuff in to keep on your desk. My wife got me this about 7 years ago at a rummage sale back in her hometown. You'll see it's made out of different yardsticks from lumber companies. This one's called the Sac Lumber Company. On this side it says for your building needs. Looks like it says Senior. It's kind of blocked off a little bit by that divider. Paints, colors to express your life. Looks like another one that said Wallpaper Company, Robinson Paint and Wallpaper probably is what it was, out of Hannibal, Missouri. So a lot of history in here. This side says over, this side says 75 years. It's kind of a cool thing that we're going to use tech for today to show us how to kind of construct this. I've been making this exact or similar to this in my class for ever since she bought it for me. Every student's pretty much had them. So if you're one of those students who has one of these still and still uses it, I know it's awesome to say thank you to me, but say thank you ultimately to my wife. And if you still have yours, go ahead and leave a comment down below and let me know you have it. But basically what we're going to do, it is essentially made up of one yardstick on the side, one stick on the other side. You got 3 pieces inside, and these two are going to be the same. However, this piece right here is going to be a little bit shorter, and we'll talk about how that works here in a second. But essentially, I think I go 12 by, we'll see what the 2 yardsticks are. I'll have to measure them right now, how tall they are. This one actually has 3 yardsticks, but the yardsticks we use nowadays from Lowe's and Home Depot and stuff are a little bit thicker, so I actually need 2 of them. So let's switch into Onshape and let's get started. Alright, so if you take a look, first thing we're going to do is we're going to draw all our parts. And there's a couple of ways to go about doing that. But the first one I want to do is we're going to draw on the front plane. We'll press Shift and S. And actually, you know what? Let's do it from the top plane. We can build them all at the same time. So N to normalize, P to hide those planes on that top plane. And what we're going to do is we're going to draw some rectangles. So we're going to start with our first rectangle. And if I measure this really quick, I know it's going to be 12 long, but for the height, we're going to go, we'll make it simple. We'll call it 1 inch tall. So we'll say 12 wide by, if we zoom out or we press the letter F for fit, we can make that 1 tall. So we'll make a 12 by 1 rectangle, 12 inch by 1 inch rectangle. And then we're going to do another one right up above it. So instead of starting right here, go up a little bit above it. And it doesn't really matter because we're just making like all our pieces essentially like a flat pack. So again, 12 by, oh, I made it angry because it was already 12. So a couple of things I can do. I can say, hey, this and this need to equal one another, and this need to equal one another by pressing E. So those have those same dimensions. We can come in here and you can see that's 1, that's 12, and they are driven dimensions, or driven dimensions, sorry, that are being driven by these dimensions down here. So yes, they are the same. We need 2 at 12, and we're actually going to need 4 at 12. So I could have done this as a pattern, but essentially, if you want to get better at drawing or trying some different techniques, this would be the way to do it. So I'm just going to draw way bigger and show you that and that need to equal, and that need to equal. So we have our 4 pieces at 12. Now, if we switch back over, we know we're going to need some end caps, and this is what kind of messes my students up all the time. I'll try to show you. This one is sitting inside these 2 pieces right here, but what we actually want to do is cap it. I like capping the end. So if we do a little bit of math, our 2 bottom pieces are 1 and 1, so that's going to be 2 inches, plus our thickness. And our thickness on this one, measure this really quick, is it's kind of swollen and changed over time, but it's about 1/8 of an inch. So we're going to draw another rectangle. We'll switch back over. We'll draw a rectangle that has the thickness. It's going to need to be 1 plus 1 for each of our bottom pieces, plus 0.125, which is 1/8, plus 0.125. So I could have done this ahead of time, done it on a calculator, but again, you can show this in Onshape, and those are going to be, if you look down here, those are going to be our cap pieces down here. So that's what's going to help us kind of get that math done. So I can press enter, and it's still going to be 1 inch tall. So I'm going to need them at 2 1/4, and I'm going to need another one exactly like that. So I can just say, hey, let's go from here to here. That's going to be the same. Let's make that. We'll use the equal, though, and that need to equal, and that need to equal. So if I ever change this, actually I can say this and this need to equal. Oh, we broke it. So if I were to change one of these to 2, those should change accordingly. I'd have to go back in and set up all those relationships, but essentially I have my 4 pieces and I have my 2 end caps, and my last one's going to need to be a little bit shorter. So we're going to draw one more, and it's going to be the same width. There we go. We'll go right here, and it's going to be almost the same size. It's going to be a little bit shorter, and it's going to be 1 minus 0.125, or we could have wrote 7/8, because we need to account for the thickness. We'll switch back over. We need to switch to the account for the thickness of that bottom plate, because this piece sits up on top, but ultimately is flush up here. So we need to account for that thickness. Okay. And for our dimension here, it's going to be 1/4 inch smaller than that outside. So if we said it was going to be 2 2/4, well, that means this one needs to only be 2, because we're going to take that 1/4 off total, each thickness of that 1/8. So I have all of these pieces drawn now, and like I said, these are 1/8 of an inch thick. So we're going to extrude them all at 0.125, and if you don't know that decimal, you literally can type 1 divided by 8. If you look right here, you'll see 1 divided by 8. We'll say accept, and you'll see we have 7 different pieces. Alrighty, so we jump into our assembly. We can insert our parts. So we'll say insert, we'll click the whole part studio, and we'll say accept. So now what we're going to do, we're just going to go ahead and right click this light blue part, and we're going to say fix. I could assign it to the origin with a fastened mate, but for what we're doing, we're just going to go kind of quick and dirty, get this thing put together. So let's fasten these things together. I'm going to take this face here. I'm going to hold down shift so it doesn't move around and select another face. You'll see as I do this, it starts to kind of go crazy. But if I hold down the shift key, once I'm hovered over that face, I'm going to pick that point there and this bottom point here, and those are now together, and you'll see that if I try to move them, they no longer move together. However, if I move these, they work like so. So next thing we're going to do is do another fasten mate. Same corner on this one, but this time we're going to come over here to this bottom corner. We're going to let it catch up. There we go. We'll click that bottom corner, and right now it's living inside the same spot, so if we rotate it, you'll see that it lives, and now it goes to the spot that we want it to. Okay, one more time, we'll do it up here. And right there, bottom corner there. So same thing, it needs to be rotated, so we'll rotate it one time, click accept, and now we have our walls, our floor and our walls, and we're ready to go and tackle these two. So next thing we're going to do, we'll start with our light kind of grayish bluish piece. We'll pull this bottom corner, fasten mate, and we'll go to this bottom corner right here. It's out that way, so it wants us to rotate around, also flip across that axis. We'll say OK, and do the same thing on our orange one. And this time, let's pick it from this bottom, and we'll go here to that bottom point right there. So again, rotate and flip, and we have our box without a divider. So a couple of things you could do. You could go in, you can press the planar mate here. The shortcut key for all the mates, remember, is the letter M, and that'll bring up your mate menu. But what we're going to do, so we can see, is we're going to hover over this planar mate so it can tell us a little more about it. So what it says is it says allows transition along the X and Y axes and rotation about the Z axis. The first selection serves as the movement point and the second as the stationary point. So essentially what we want to do is I want to make this gray divider. Let's move this a little bit. We'll go 90 that way, and we'll go 90 that way as well. So I want that to sit and pretty much run right across this slot right here. But you can come up with a bunch of different customization options and variations. So again, if we go that planar mate, the one that we select first serves as the movement point and the second as the stationary. So what's going to move? This. What's going to stay put? This wall. So we are going to do planar mate, and again, what's going to move? I'm going to select this top corner right here, and then we're going to come over here and we're going to select that top corner, and you'll see that, let me kind of zoom out a little bit, move that guy out of the way. If I press play, it's giving me freedom around that point in all of the different directions. So it's probably not what you want. If we go ahead and click the green check mark and I go to move this, I don't want that, right? I don't want that piece. It's impossible to make that happen. It is paying attention and going certain ways, but right now it will never go below this, and so that's kind of what we were looking for, but it's still going through these other walls. So another trick I wanted to show you is if you double click back on planar, and actually let's undo all that movement. There we go. Now we'll go back to that planar. I can actually set some offsets like you've done before, but I can set limits. So here what I'm going to do, I'm going to press play, and we're watching that, and so it looks like my X is going that way. So if we were to look from this way, the way I oriented it, X is actually my Y axis here. So we're going to say 0, and then we'll tab 0, and then we'll solve and play again, and let's see what happens. So now it's sliding the way I want to, but I want to get rid of all this rotation. So nothing on the Z, and on maximum, nothing on the Z. Minimum, we don't want any degrees of rotation, so let's solve again, and we'll press play. and now it's only moving one direction. The problem is we need it to swap directions. So no minimum, we're going to say 0. So solve, play, okay? But now we want it to go, and we know that our piece is 12 inches long, but we can't have it go, oh, I guess we could have it go the full 12 because these are 12, yeah. So we'll just tell it here, go 12, enter, solve, play, and the problem is it's pushing it that way. So if we say negative 12, enter, solve, and play, it's going to run that through all of these like so. So if we say okay, and we come back, I can't move this backwards. Oh, it's stopping at 12 there. Oh, there we go. So what needs to happen is we do need to give it a little bit of an offset. So no maximum should be negative 0.125, or sorry, 0.125. And this needs to be negative 12 plus 0.125 because we forgot to add that for the thickness of the piece. So if we press play now, so it's working. Let's go back to 0. Let's see what happens. Let's solve that. There we go. So we had to add the thickness of that piece. It was throwing itself all the way over here. Let's say okay. And I can slide along. It's moving pretty slow. I can slide along this channel and it should stop. Once it bottoms out, let's go for the top view. Now once I get to this end here, it is not letting me go any further, but if I go this way, I can set it in a bunch of different variations. Maybe I'm gonna sell this as a product and I'm gonna put some pencils with it. Maybe I want to see what else I could put in. Maybe I want to add some more dividers, whatever, a bunch of different configurations. But you'll see it won't let me go past those two pieces anymore. And if I were to right click this and press animate, we'll say the Y planar mate, we'll say you can have that animate itself back and forth, and reciprocate is going to show those limits. I could speed this up a little bit. We'll go there, and we can see kind of how that thing's moving accordingly. So that's going to do it for us today. Again, very, very simple box. I will do another video on this, probably with the completed actual box for when my students start doing it again. That'll probably be around December-ish. They're actually learning Onshape right now in class, so it's a cool thing. I want them to be able to draw this up and to go from there. So if you have any questions about the Planar Mate, feel free to give me a comment down below. Next week we'll be talking about cylindrical mate, which is pretty similar to our Revolute mate, but it's going to act like a cylinder. And now that I think about it, I probably should have done the hydraulic cylinder for the cylinder video, but there's a lot of other things that we can use for a cylindrical mate. So that's going to do it for us. I hope to see you guys next week. Take care.